The NFS kernel server. The network file system, NFS for short, is the standard originally established for sharing directories between Linux and Unix systems. Shared NFS directories are listed in the etc/exports configuration file. But before you start editing this file, you'll need to install the right packages for NFS: portmap, nfs-common, and nfs-kernel-server. To install them, I ran the sudo apt-get install command followed by the names of those packages. Now let me explain a few examples of shared directories as configured in etc/exports. For example, this first line here, associated with the home directory, exports that directory to all systems on the noted IP version 4 network. Exports of this share are made in read-write mode. Reads and writes are done in sync. If I wanted to share it in read-only mode with a different network or a different IP address or even a domain name, I add to the end of the line the IP address or domain name associated with the network, followed by the permissions, in this case read-only and sync. One important option for certain shared NFS directories is no root squash, which allows root level access, which can be important for things like terminal servers. When changes to etc exports is complete, you actually need to export them, and that's made possible with the exportfs-a command. The second time you change the etc/exports configuration file, you can just restart the NFS kernel server or export the shares with the exportfs-r command. To confirm that directories are shared, you'll first want to be on the local system, from where you can run the showmount-e localhost command. Make sure the NFS server works. NFS doesn't run properly without the portmap package on the server or the client. It's the first thing I check if there's trouble with the connection. I restart the service with the following command: etc init.d portmap restart. Once the service is restarted, try the rpc info-p command. See the services which use portmap. Analyze this output carefully. First, it tells me that portmap, rpc.nfsd, and rpc.mountd, these daemons, along with a couple of others, are running on the local system. Look at the version numbers under the vers column. Examine the protocol under the proto column, whether it be TCP or UDP. Note the port number. For example, at the top and the bottom of the output, there are different entries for the portmap daemon. One on TCP, the other using UDP. Both are communicating over port 111. Note that both TCP and UDP protocols are used for communication for versions 2, 3, and 4 of the NFS daemon. Note the similar situation for versions 1, 2, and 3 of the mountd daemon. We've reviewed portmap related services. You should also be aware of potential syntax problems. The etc/exports file can be finicky. If exports aren't properly showing out in the output to the showmount-e command, there may be an issue with that file. Extra spaces can lead to errors. The extra space I show here after the comma in the rw, would lead to errors that mean the directory doesn't get exported. Of course, if you're sharing with remote systems, you'll want to check the exports from NFS clients. To do so, run the showmount-e command directed at the host name or IP address of the NFS server. Let me do this on a remote NFS server, and I see a good export list. But if there are problems, it's worth checking the network. If it's a physical network, are the physical connections solid? If it's a wireless network, are both systems connected to the access point? Is the port map service installed on both the server and the client? Don't forget, firewalls may be an issue as well. As firewalls are not covered in the UCP curriculum, let's just check iptables firewalls with the sudo iptables-l command. No firewall rules blocking communication here. Mount a NFS share. Before mounting a shared NFS directory, you'll first want to verify what's available, and that's made possible from the command line, courtesy of the showmount command. Of course, if name resolution is properly configured, you can specify the host name or even the fully qualified domain name of the NFS server. But for the purpose of this video, I'll keep things simple and specify the IP address of the NFS server. So I run showmount-e to read exports from my NFS server at IP address such and such, and I see the exports from that server. To mount the directory locally, you'll need an empty local directory, as your account should have permissions to that directory, especially if you want to write to it. I'll create it in my home directory now. Let's call it NFS mount. I'll need administrative privileges to mount with the NFS file type from the remote server at this IP address. That's the shared directory, and I mount it locally on the NFS mount directory that I just created. I verify the result, and there we go. Those are the files from my home directory on the remote system. The permissions I have on that directory depend on a couple of things. First, the share permissions as configured from the NFS server. In the etc exports configuration file on that server, is it shared in read-write or read-only mode? Of course, it also depends on whether the local directory is owned by the user in question, and we made sure of that by creating the mount point in the target user's home directory. Basic Samba shares. Samba is a Linux implementation of Microsoft Networking. It emulates the network features associated with Microsoft operating systems through the SMB or the Server Message Block Protocol. It's been updated for CIFS features. That's the Common Internet File System. To review basic Samba shares, make sure the Samba and Samba Common packages are installed. On clients, you'll also need the SMB-FS package. The Samba server is configured in etc/samba/smb.conf. And in this video, we'll focus on share definitions. Normally, the directives associated with the home stanza are commented out. In other words, they have a semicolon in front. The semicolon and the pound sign are both comment characters. But for the purpose of this video, I've activated the home share. By default, home directories are set to be shared as read-only, but I set it to read-only equals no, which makes it writable. A double negative, yeah, I know. The create mask determines the permissions for files that are created or copied to the shared Samba directory. And the directory mask has a similar purpose for directories created remotely. At the end of this configuration file, I've added another stanza for the temp directory. I could name it something else in brackets, and if I put in, say, temporary within the brackets, that would actually be the name of the share and what I would have to use to mount the share remotely. But it's customary to use TMP, so that's what I do. And the path is to the /tmp directory. It's not read-only, so it's writable, and it's public, which means it's browsable as well. We save the changes, and then we reload the Samba service. Reloading has an advantage over restarting. If you restart Samba by substituting restart for reload, you actually disconnect any clients that are currently connected. And you want to be considerate of your users. So we reload, rereading the new Samba configuration file. And then let's create a Samba username. Sudo smb password -a. We're setting up a Samba user by adding it. That's a -a. I specify a username, my own username. I'm prompted for a Samba password. I'm prompted to confirm. My account is now added to the Samba password database, which is different from the regular password database. I've gone over the home share, I've gone over the temporary share, I've reloaded the new configuration file, I've created a Samba user. Now let's go to the remote client. And apply the smb client command. We list the shares with the -L and then specify the host name or domain name or IP address of the remote Samba server. I don't have to enter a password to see shares that have been shared with everyone, and I can see the temporary share, which has been shared with everyone. It's been made public with the public equals yes directive. As you can see in the middle of the output, it's an anonymous login. However, if I wanted to see the share of my home directory, I could add the -U followed by my username. I enter the Samba password created a moment ago on the remote Samba server. I do that. It's no longer an anonymous connection, and now I see the share name of my home directory. Now let's mount that particular share. It's made possible courtesy of the mount.cifs command, since it has what's called SUID root permissions. It's usable by regular users without having to resort to the sudo command. Mount.cifs is part of the SMBFS package, so if you can't find this particular command, make sure SMBFS is installed. But before we do that, let's create a mount point for which I have permissions. So I create a new directory in my home directory, call it Michael2. Now let's use the mount CIFS command to connect to the share from the remote system. The share name is Michael, and the mount directory is home Michael2. I'm prompted for a password, and strictly speaking, I should have entered -o username equals Michael. Let's skip that for a moment. -o, and I'm prompted for a password. That's the Samba password on the remote Samba server. And let's review the result. These are the files from my home directory on the remote Samba server. As it's been configured with the read-only equals no directive, I can take a file locally and copy it to the remote system. NFS and the shares-admin tool, the UCP curriculum, specifically cites the shares-admin command, which opens the shared folders tool in a GUI. It can be used to configure shared NFS and Samba directories. The first time it's open, and let's open it here. To get access to this GNOME administrative tool, I have to click Unlock. I enter in the Authenticate window which appears. I enter a specific user, a member of the admin group. I specify the password for that user. I click Authenticate. And now I have administrative access to the shared folders tool. Now let's create a shared NFS directory. I start the process by clicking Add. It opens a shared folder window. From the Share Through drop-down text box, I can pick Windows networks or Unix networks. Since we're creating an FS share, we want to select Unix networks. Then in the Path drop-down text box, we want to specify a directory. If the directory is not available locally, I can select Other and navigate to that directory. But for the purpose of this video, I select Documents, which is the home/Michael/Documents directory. Now I specify what systems are allowed access to this share. And I can do it by host name, which is more flexible than it looks because I can enter fully qualified domain names such as star.example.org or star.example.org, which would allow access to all systems in the example.org domain. I can specify an IP address, and that would have to be a single IP address. I can also specify access to a specific network, and that's what I'll do for this video. Share it with all the systems on my local private network. If you want to share in read-write mode, don't activate this option. If it isn't activated, read-write mode is assumed. I click OK. I click Share. I see the share now in the Shared Folders tab. And let's see what share has been created. We'll review the result in the etc/exports configuration file. And look at that. The home/michael/documents directory has been shared with the local network in read-write mode. To make sure it's actually shared through the local NFS kernel server, I run with administrator privileges the sudo etc/init.d NFS kernel server restart command. And I can confirm the result with the show mount-e localhost command. And there it is, the shared directory, now in the export list. The Shares Admin tool and Samba. The UCB curriculum specifically cites the shares-admin command. When run in the GUI, it opens the Shared Folders tool. It can be used to configure shared Samba directories. The first time it's open, the main Shared Folders tab is blank. Whatever the current status, the next step is to click on Lock. In the Authenticate window that appears, I select my account, which happens to be a member of the admin group, and enter my password. I select Authenticate, and now the Add button is active. I can make changes. I click Add. That opens the Share Folder window. With the Share Through drop-down text box, I see I can create Samba or NFS shares. Let's stick with Samba shares since that's the subject of this video. With the Path drop-down box, I can select the directory of my choice. If the directory is not shown here, I select Other and navigate to that directory. Let's stay with the default for now. I stick with the standard name for the share, in that case my username, and I add a comment. Let's call it my home directory. I make sure the share is not read-only, so it's writable to authorized users, and then I click Share. I see the shares implemented. I can check it by highlighting it and clicking the Properties button. But let's see what this has done to the Samba configuration. I click Close, and then I review the output in the main Samba configuration file, etc/samba/smb.conf. And I see the changes I made are implemented at the end of the Samba file. The share name is Michael. That share is based on the path to my home directory. It's the comment that I entered. It's available, browsable, publicly viewable, and writable. But that's not it with the Share admin tool. Let's open it up one more time. I see under the General Properties tab, I can set the domain name or workgroup of my choice, preferably the one associated with the local Microsoft network. And I can add users as needed. Let's add a user. I click on Lock again. I authenticate. And let's add a specific user. The username is actually different. This is from the user description in the etc/password file. And the password I enter becomes the Samba password, which is a different database than the standard authentication database in etc/password. Add now the user associated with the name Dickens the cat. In this case, user Dickens can access shares that this cat is allowed to access by appropriate permissions through the local Samba network.